Hi, everybody. My name is Matt. Hi, everybody. Thanks for coming today. We got a nice packed room. That's really nice. I'm guessing everyone's really curious about Docker. It's a cool new tool that everyone seems to be talking about these days. And thanks to all the organizers again. It's a really great opportunity for me and for everyone here. And I hope everyone's going to have a good time. So just real quick, my name is Matt Wright. You can find me on the internet at various places under Matt Upstate. I'm a software and ops engineer for a company called ChatID. We use a lot of fun stuff as listed here. If you want to talk more about that, catch me later. I'm happy to talk about it. I also do some open source work, primarily in the Flask community. I author and maintain a few extensions, contributed some other bigger projects, and I'm also a member of MetaFlask, which is kind of a new loose organization of, or group of people involved with perhaps defining the future or helping maintain Flask. We're here to talk about Docker, right? So what's all the fuss about? I'm really curious, just in this room, how many people are already using Docker? So quite a few of you. How many of you are using Docker in production? I don't know why you're here, but at any rate, but it's good. So yeah, Docker's a new tool. It's great. There's a lot of things happening around it. But for all of you that don't know what Docker is yet or haven't used it, this is kind of the stock quote from their website. It's an open platform for developers and sysadmins to build, ship, and run distributed applications. It's kind of vague in a way. But it is probably a good way to sum it up. But more specifically, and not to get too low level, Docker is a tool built on top of Linux containers. There's different implementations of containers. We don't have to get into that. It doesn't really matter. This is more about how to use Docker with Python. But before we even get that far, I just want to cover some concepts that Docker has. The first being images. Images are basically snapshots of a Linux operating system that you can then deploy or use to run code in. You can do a whole bunch of different things with them. And containers are what you have when you take an image and you quote unquote run it. And a container is stateful, meaning that anything that happens within the file system that was started from the image, it means it changes, it stays around until you decide to perhaps save it for later use. You can turn it into an image if you'd like. There's also there's some core components of Docker. The first one being the Docker engine, which is a lightweight daemon that runs on your server or your laptop or whatever computers you want to use Docker on. And that helps manages your images and your containers on that computer. And then there's also the idea of the Docker Hub, which is a place that contains repositories for images for you or your organization to be able to share with other people in your organization or the public. And this is just a little diagram, a bird's eye view that might explain it for people that might be a little bit more visually inclined. So on the left you see this is the Docker Hub component, right? It's basically a web service that Docker, the company, has a service that they offer for public repositories and private. So basically the hub is just a collection of repositories, and each repository has collections of images in them. Images can be tagged. And then you also, on your server or your laptop or VM, wherever you're running Docker, you have the Docker engine. And you also have the Docker CLI, which is the more or less the machine or even human interface to the Docker engine, which communicates with Docker Hub. It pulls images, it pushes images, and it manages images and containers on that machine. So Docker has a whole bunch of use cases. First being, for me, development environments. That's one of the big things we'll talk about, or I'll talk about today. Application deployment. Docker makes things easy to deploy, arguably. It's also great in continuous integration and continuous delivery systems. And hopefully something I'll show a little bit later will illustrate that. And a lot of people are starting to build Docker into into their platforms or their platform as a service offerings. And I'm sure you'll see even more uses in the future. I mean, Docker is really new and young, and it's still, it's just, there's a lot of movement happening now. So currently the landscape of Docker as far as like tooling and platforms and SaaS offerings looks, these are just a few items in that landscape. For instance, AWS, Elastic Beanstalk Service, supports Docker now, which is pretty cool. You can get apps up and running really quickly and easily if you're using Docker. Another product that I am kind of curious about, it's still pretty new, is CoreOS. It's kind of a distributed Linux clustering thing. Then it's got Docker as a core component of it. In the tooling department, I'm really happy about this tool called Fig, which I'm going to illustrate how to use later on. And there's some new, some of the existing like CI offerings, like Circle CI. They just announced Docker support in their system, so that you can run and build containers on their platform. And also, I think it's pronounced Quay. Someone told me it was pronounced Key, but I'm going to call it Quay because it looks like Quay to me. Quay.io is an alternative hub to the Docker official Docker offering, which looks pretty cool. And I'm sure there's going to be plenty more to come in the future. So if you're not using Docker yet, and if you're on OS X or Windows, you'll probably want to use this tool called Boot to Docker. It's a lightweight VM that's got Docker built into it, and it's designed to try and make it easier for you as a developer to use Docker on your machine if you're not on Linux. If you're on Linux, if you're on Ubuntu, Fedora, whatever, you're good to go. But OS X and Windows has a little, you can't do Linux containers natively on those systems, so you use a VM. And this link specifically is a link to a post on CoderWall, which actually has some instructions on how to set up Boot to Docker on OS X specifically, to set up a shared folder with that VM, because sharing a folder with that VM will make working with Docker from your OS X machine much easier. Unfortunately, I don't have a link for Windows users, so I'm sorry about that. So let's get to a little bit more specific. So Python and Docker, right? And to be quite honest, like this is about Python and Docker, but really this could apply to almost any other language. I know many of you probably program in other languages, but the big thing for Docker and Python for me personally that I want to talk to you about is development environments, because development environments are a pain in the ass. And I know if you don't think they are, then I would think you've solved something that people have been trying to solve for years and years and years, right? So why isn't this? There we go. Okay, so development environments consist of usually an OS, system libraries, your Python dependencies, and potentially databases and caches and things like that your application needs to run. And there's always problems with this, because as your code travels from your computer to other computers in your infrastructure or in your organization or whatever it is, there's going to be differences. And those differences constantly change. They're never truly consistent in my experience. Sometimes you have an ops team that handles all your infrastructure for you, and there can be miscommunication as to what the system dependencies you might need on a system and whatnot. And that just causes problems such as what I call drift. Like over time, a system, a long living system might be getting updates, and some of those updates can happen unbeknownst to you and cause problems with your application down the road. And so people solve this before by just writing readmes. We've all probably seen those readmes, like do this, to get your development environment running, and that's just awful. And then people came up with stacks like LAMP and XAMPP, which are really popular in like the PHP Apache world, and those were good. Those were pretty good, really, for that kind of problem. And then virtual machines and virtual machine management became pretty cool, a la Vagrant, and then Vagrant started supporting provisioning through Chef and Puppet and Ansible and such, that you could then perhaps, if your organization was organized well enough, share the same perhaps chef recipes or Ansible playbooks with your developers to provision your virtual machines the same way that you do in production. But let's be honest, it's never really the same. So that's why I love Docker. Docker, you can be, like, you as a developer can be in charge of your development environment. And that same environment can be used to be deployed to staging, to QA, to development, whatever, to production even. And the best thing about Docker is that it's easy to change and share your development environment, such as through a hub, either if you have a private or through a public one, if you're working on perhaps an open source project. It should be consistent all the time because images are snapshots, and as long as you share those same images with everybody or tell everybody which image to use, it should be consistent. Linux containers are nice and isolated, so you shouldn't experience any sort of overlap or something between systems. I like this idea of the single authority, so if you're in charge of your application, you get to decide, no one else does. Unless like your ops team says, hey, you're doing it wrong in your Docker file. We'll get more to that later, and that's good. And in theory, your Docker environments should be production ready. You should be designing them, or your Docker images, to be as close to a real system as possible. So how do you create this environment, right? So you have to create an image, a Docker image, and the way you create a Docker image efficiently is with a Docker file. And a Docker file defines a set of steps that the Docker daemon running on your machine will follow to create a file system and take a snapshot of it. So for instance, a Python application Docker file might look like this. Make that a little bit bigger. This is a very simple Docker file that in the first line, the from line, is telling the Docker daemon to use a publicly available base Ubuntu image. And by the way, 1404.1 is the image you should be using, not 1404, because that one has .1 has security updates that you should all have. Everything in green obviously is well, not obviously, but is a command that Docker understands. And what run means, it tells Docker to run this command on the image. And in this case, the first couple of runs are just upgrading packages in the system, just in case there happens to be some updates available in public Ubuntu repositories since the time the image that we're using was created. And then we're just installing a couple system packages such as Python dev and Python pip. And really, that's the most basic Python environment that I can imagine. Now, you'll see on line 8, we have the add command. And in here, I'm adding the current directory via dot into the /code directory. And what that's telling Docker is to put this entire directory, which happens to be my project, which includes the myapp package, the test folder, and a couple other files such as the setup.py and the whiskey.py file. This is a basic Flask app. I thought that Flask is popular enough and web application development is straightforward enough and popular that it might be a good example. So what I like to do also with my Python applications is install them as if it was a Python package and not just let the code just sit there. And so I think that's a good practice. You don't always have to do that. But here you see before I install on line 11 my Python package, my application as a package, I'm telling Docker, what the work directory should be. So all the following commands after this work declaration will run in that directory. A nice little convenience. And the last two lines, expose is telling the Docker daemon what ports will be opened or want to be opened on this container when it is run. 5000 happens to be the port that this Flask application will be running on. And the cmd command, or cmd directive, tells Docker that this is the default command that should be run if somebody tries to run my image and doesn't pass in a command themselves. In this case, we'll just run the Python application, and that is done by pointing the Python runtime to the whiskey.py file. And so luckily, so when, well, at any rate, so now we have a Docker file. This is the basic Docker file that I've designed for this application at the bare minimum that it needs to run. And so the way you build your image from that Docker file, this is the directory that I'm in. So you'll see the Docker file, my app package and whatnot. So we're going to do, actually I already did this. So this is the command to build your image from that Docker file. So Docker build, the -t flag tells Docker the name of the image and the tag. If you, an optional tag, a tag would be like colon, you know, some tag. In this case, I'm not using a tag. And then you also tell the Docker daemon, you provide it with context, and context is the current directory that it is, that the terminal is in. And what that does is it sends the entire contents of that folder to the Docker daemon, so that it has everything it needs to build the image. This should hopefully be fast because what Docker likes to do, it uses a union file system and it caches things it built before. So it doesn't have to rebuild it. You can tell it to not use the cache if you have that, if you have a reason for that, and this should be pretty quick. So there you see Docker went through all my steps, and luckily it used the cache because I found out that the PyPy index does not like to be able to be reached from Docker on this network for some reason. So now we have an image with my application code in it, and now I can run my application with here I'll clear that, and then this is how I want to run my application via Docker from the image I just created. So we use the Docker run command. The RM flag is going to basically just tell Docker to remove the image after the application quits. I don't need to keep it around for any reason. Actually, sorry, this is not the command I want. That is the test command that I was supposed to show you afterwards. So let me just fix this. All right, so I need to tell it the port that I want to expose. I won't get too specific about that. And so there. So now my application is running in a container via Docker. And if I go to, so this is, remember how I said that it's good to use boot to Docker? So because it's a VM, it has a different IP, so there it is. So my app is running, it just spits out hello world for now. Now, this is cool. Oops, let me just go back to, so I forgot to attach the interactive terminal, so I can't send a signal to it to kill it. But at any rate, so that's cool. So we have an image with our application in it, and we can run the application just like that. Now, what's even cooler is I can run my application tests in this container without doing really any more additional work. It's just a fun new command line call, and I'll try and explain this. Let me just PS grep PyGotham. Ugh, there it is. Docker kill that one. That should have killed it. Yes. Okay. So now I want that command I was almost going to run earlier here, right? So with that image, I have my nice environment for my application to be in. And when you run Docker, you can also attach a path on your file system to the container. So what I can effectively do is I can override the existing code of my application with the contents or the changes that I've perhaps made to my application and its tests by passing the -v flag, which you'll see here. And all I'm doing is I'm passing the current working directory through the pwd command and putting it in /code, that same folder that I put my code in via the Docker file. And in this case, I'm going to give it a new command to run. I'm not going to let it run my application. I'm going to pass it the pytest command and run my tests. And voila, I didn't have to do anything extra. I can just run my test in the Docker image, the same environment, the same dependencies, the same OS as I will be using in theory in production if I deploy my application via this Docker image. So I think that's really cool, because now you have this Docker image. You can give this to anybody on your team to develop and test any new code for your application in. And if I have to make changes to it, I can do it simply via the Docker file. Now, so Fig, right? I mentioned Fig. Fig is a tool that helps orchestrate doing kind of what I did before, but perhaps with some service dependencies, such as a database or a cache, Redis, Memcache, what have you. It's built with Python. You can simply install it with pip. And Fig uses a YAML file for you to define your services. And it looks like that's the full one. We want Fig. Here it is. So this YAML file looks like this, right? So you can see I've defined what's called a web service. I'm not going to get too specific about Fig, but the top level directives in your Fig file define your services. In this case, I'm defining a web service, and this should look similar to what we did before with the Docker file. The command is the default command that runs the application. Build tells Fig to use a Docker file in the current directory to build the service from. I can also tell Fig to mount some volumes to the container when it happens to run the container. And in this case, you can see I'm using basically the same thing I did just before to run the test, and that's mounting the current directory to /code. But in this case, Fig also lets me define a DB service. And in this case, I'm telling it to use the Orchard Up Postgres image, which is publicly available. And that image is designed in such a way that you just have to pass it some environment variables, which you can do through the Docker command line tool. And those environment variables will create a database with a name of your choice and a user and password of your choice. So that image is designed specifically for this kind of use case. And I'm also telling Fig to link the DB service to my web service for me automatically. Kind of nice. You might have lots of other dependencies depending on how complex your application is. I'll do questions at the end, sorry. So we'll see, just to show you the Docker file, it looks pretty much the same, except we'll see we've added the libpqdev system package, which is required for Postgres client. And this application just happens to just commit something to a database just to show that it's actually working. But what happens with Fig is when Fig links the DB service to your web service container, it provides it with some environment variables that you can use to construct configuration values. And in this case, I'm using these environment variables to construct my SQL Alchemy database URI. And if you're curious what those environment variables are, because they're not always so apparent, you can from the command line use the Fig command line and say Fig run web, which is the name of the service, and just pass it the end command. And Fig is just basically going to print out all the environment variables that are going to be available to that service when it's run. And in this case, you can see there's a whole bunch of fun stuff in here. It happens to be the Postgres password and user and database name, and even some networking stuff that you can use to construct configuration values. So now I can run my test via Fig. I don't have to do anything special because I've declared my service dependencies, and now I can basically do the same thing as before. If I want to run my tests, I can do Fig run web pytest tests, and my tests happen to pass. And that basically just did the same thing I did before, but with a little less command line flags and things like that to keep track of. And the other nice thing, remember how I talked about Docker's use cases and continuous integration and deployment? This is what I think is really going to be convenient for most people. If you have Fig and Docker installed, and perhaps Jenkins or CI service that offers that, this is going to be basically your test command. And you don't have to have the databases running or services all set up in your CI system already. You can do everything with Docker, and Fig will orchestrate all those dependencies for you. And Fig will also spin things up before, so that it'll spin up the DB before your web, and it knows that because you've linked them together. Great tool, does a little bit more than that. Docker just acquired the guys that wrote Fig, so I can only imagine it getting better in the future, and perhaps even be integrated perhaps with some deployment platforms at some point, who knows. So Fig is cool. So let's talk about getting a little bit more production ready. If anybody that's written web applications with Flask before knows that you shouldn't run the application just through Python and the built-in web server. So in the case of a web application, you might have some other dependencies that you want to install into your Docker image to make it more production ready. And that, for example, if we go to this Dockerfile example, what I'm actually doing here is I'm installing Nginx and also uWSGI, which are common tools for running Python web applications. uWSGI is a nice way to run WSGI applications in general, in a performant way, does concurrency for you and stuff like that, and everyone loves Nginx for doing static files. But the difficulty with this is that when you install these tools, they're not necessarily set up to work exactly like they perhaps should for, in a Docker image. It's generally good practice to have your processes in your Docker file or in your Docker containers logged to standard error, standard out. You can configure both of these tools, Nginx and uWSGI, to do that. The trick will be here is that we're going to be running two processes, and that's going to be the uWSGI process and the Nginx process. And the way you do that in a Docker image is to use a run script. And the run script, in this case, I'm basically running uWSGI and Nginx in the foreground and redirecting their standard error output to standard out, just to make sure that everything's all going to be catchable by Docker. Because what Docker will do is it will take all the standard error and standard out from your container and log it and keep track of it. And there's tools surrounding logging in general with Docker that can then take those logs and then you can ship them off somewhere. It's kind of a nice mechanism that Docker offers. So it's good, in a way, it's good practice to do this with anything that you run in Docker containers. So, for example, I'm going to, let's see here, just show you an example of what that looks like. When you run it, I'm not going to build it, but here we go. Now we can see I got the uWSGI logs and the Nginx logs coming in standard out. And as long as I did the port correctly, pull that off there. So just to show you, that's my Docker VM IP, and now I'm running my Python application with production level software on top of it, all within one container. And now you have this container could arguably then be distributed and deployed to multiple hosts and be load balanced, perhaps with some other software, Nginx itself, HA proxy or ELB or whatever it is you happen to use. So cool thing is too is we can still do the we can still run our tests. It's basically the same environment. The only additional dependencies were Nginx and uWSGI, and they don't really get in the way of us testing anything because that's all done with Python. And just to show you, you can use that same image just as before. So those are some workflows that I really like with Docker surrounding Python applications, specifically a web application. Docker can also be used for applications that are not web applications. You can run Celery applications, you could do RabbitMQ consumers, you could do all sorts of stuff. It doesn't have to be limited to web applications. So with knowing that, I think there's some tips that people need to be given with Docker. It is such a new tool, and there's a lot of kind of signal to noise ratio problems with Docker right now. And I want to give you some tips before you could perhaps go use Docker. There's a lot of people that say you should only run one process in your containers. There's some people that say it doesn't matter. Some people say you should run SSH in your containers so you can get into them. Some people say you shouldn't. So be skeptical of all Docker dogma right now. It's a new tool. It can be used in lots of different ways, and there's no one way or right way to use Docker right now. So as mentioned before, for instance, with the Fig tool, environment variables are a very popular thing to be able to give information to your containers. Docker uses them when you link things, we link containers together, and that's really handy. But they can be overused, in my opinion. You'll see a lot of people saying that you should pass like passwords and S3 keys and things like that through environment variables. I think that's a bad idea because envars from one container can be leaked to any other containers that are running on the same host. So if you happen to have a password or something like that set in an environment variable, any container that starts up on the same host can say, I want to link to this other container and get those environment variables. And that's not such a good thing. So there's lots of ways to deal with secrets. I'm not going to get into that, but just don't put them in environment variables. The next thing is you don't have to use Docker for everything. A lot of people think that, oh, I'm going to adopt Docker right now. This is something that I've been seeing or reading about, or seems to be a common thing, is you don't have to use it for everything. There's cases for using it. There's cases for not using it, depending on the software. That said, Docker can be really helpful for a lot of applications. So make the best judgment call based on what you know about your software. And the last thing is design your images carefully. Design them to be flexible, depending on the context that they might be run in. Configuration is obviously a difficult problem, as I was talking about before with environment variables. There's lots of different ways to do that. You can mount volumes to your containers to perhaps get pre-rendered configuration files. But think about how other people might be using your images and make it easier for as many people to use them. For instance, with the public Docker registry image, they have different like config flavors and things like that, and there's ways to tell it which flavor to use. So design them carefully, and don't forget that this Docker does not preclude you from being smart about Linux administration. So if you don't know what you're doing with Linux, get some tips. Perhaps if you have an ops team, read up on good practices with Linux packaging, and just make sure for sure that you're doing things okay in your images, because I think it's going to be really easy, especially for people that are a little bit ignorant, because Docker makes it so easy in a way. I think it just make people ignorant, not because I'm not ignorant in like a bad way, but just because you don't know. We're all ignorant about a lot of things. Yeah, so just remember, get somebody that maybe knows Linux to look at your Docker files and your images to make sure that everything's okay. So that's it. So thank you. Questions? I know you tried to get in earlier, so I'll get you first.
So regarding Fig, you have a Fig YAML file.
Mm-hmm.
Does that run in any step of the Docker file? Let's say you want to, after config the database, you want to create like a schema, or you want to like set up the proper environment.
Right. So so you're wondering about, are you thinking specifically about database schema within
how would you run some things after the Fig YAML?
Okay, so with Fig, you can tell it to build the container before it runs it, and when you so there's something that it's going to be hard to explain maybe, and I'll try and do it really quick without getting too complicated. But there is a project that I used Fig with where I actually had I had my app and my test DB, and then I had my schema DB, which when you develop an application with a database, you often do migrations and schema design and things like that. So I kept the schema work in a separate database. So I had 2 database dependency or services defined in my fig file. So I just left all the schema stuff to be done in one, and the test could use another one, and the test, they can, that database can scaffold up, scaffold down, no big deal, whereas the migration one always more or less stays the same. Does that make sense? Does that help? Okay, cool.
Some questions around working with Docker on team. You had like apt-get update right there, and I assume that goes in a local cache of some sort. So if all of my developers are running that, isn't there a potential they're all at different package versions because it's frozen that chain the time they ran it, and then the build server that distributes them could run it at a different time, and you have all different package versions?
Yeah, yeah, that does happen locally. That is something that I've been thinking about, and I'm not exactly sure how to solve yet. But I feel like it can be solved with having a organization base image that perhaps like a CI server or something is constantly building and tagging, and you're tagging images that do that already, so you don't have to put all that update stuff in it, like in your applications. So I think that's maybe the way to do it, but I'm not. I do understand there's like conditions where apt-get, update ran once, and then maybe there's some updates, that happen to a bunch of repositories in the meantime. But I do think that having that base image, tagging it, and telling your developers, hey, use this tag. All right, now you can update the tag for that base image. Might solve that problem. I don't know yet. We'll see. Docker is still new. It's even still new to me in many ways. So yeah, that might work. Maybe that's a good suggestion. Maybe not.
I noticed in your run scripts when you had a sleep statement.
Mm-hmm.
For example, if you have multiple things that you need to execute, that might get a little bit messy. Is there an easier way to do that?
Like I said before, like you don't have to just run one process. Sometimes it makes sense to run multiple processes. In that case specifically, it's just to give uWSGI just a quick little bit of time to start up before Nginx gets on top of it. I want to say though, like if you start getting too many processes that you need to do in that run script, you might think about separating them. But that's just something that I thought was appropriate in that run script. You'll have to make the best case, judgment yourself, depending on the software you're running.
Have you spoken to create snapshots of situations that you want to save and further troubleshoot? Like you spin up your image, you maybe test out 90 run condition, and then you take a snapshot with it to hand over to someone else, for instance?
I could see that happening. You can commit a container after it's exited, and when you commit, so you take an image, you make a container, some process makes some changes to the file system, and that process exits. You can then commit it, and then make an image from that container. That's basically what the Docker file does for you, just nicely. And then you could take that image and then share that with other people, and perhaps do what I think you're talking about, like inspect things and what happened and whatnot. So,
give a kind of a high-level description of the life cycle of a single container, maybe on the scale of like a single web request to your Nginx.
In the example I gave there at the end,
Yeah.
Let's see. So just for a web request. So once the container starts up, I'm running the Python application with uWSGI, which uses a process worker model to be able to handle multiple requests. And that uWSGI exposes a port at which Nginx can. I'm actually going to share these files with it, so you'll actually be able to get the configuration files for uWSGI and Nginx for your own use or for your own reference. But uWSGI exposes a port that which Nginx is a proxy on top of and connects to. And in the Nginx configuration file, you'll see that socket is specified in there. So web request comes in, perhaps from the public into your infrastructure. Perhaps there's a load balancer or proxy of some sort in front of that. That request gets sent to the host machine that Docker is running on. And then because I've exposed the port from my application in the container on the host, in this case the web app's port 80, that connection gets forwarded to the container, and then a request is passed to Nginx, and Nginx then forwards that request off to my Python application through the uWSGI socket. Does that make sense?
Yes. And then at what time or what signals the containers will spin down?
So it depends on the software you're running, but Docker has basically 2 commands for that: Docker kill and Docker stop. Stop will send sigterm, and kill, I forget what, I think it's I forget the exact signal off the top of my head, but that's how you can stop containers. You can tell Docker to run containers either in the foreground, or you can tell them to detach and run in a more daemon fashion. Anybody else? How am I on time? 1 minute, that's perfect. I can't believe I did that. Thank you. If you have any more questions, feel free to, I'll be around all weekend. So yeah, thanks.